our favorite quotes that you just shared.
Yeah. So I'm just sharing here some example areas of active research that could change everything. One, which is dear to my heart, is controlling the ever-present fluctuations required by quantum theory, vacuum fluctuations to generate currents and propulsion forces. That would enable unlimited satellite repositioning, maneuver without regret, or a continuous source of power, providing clean energy. NSF is supporting some of those activities. Thank you. We're building some devices. There's also all the work in extended electromagnetics. And that's an extra degree of freedom that's predicted that maybe we can take advantage of. And it really comes from the fact that potentials and not fields are fundamental. We all think the magnetic field, electric field, but it's been proven through the Aharonov-Bohm effect, which is illustrated there, that even without fields present, the potentials have impact on electrons and other things. And so that could enable new communication pathways, EM weapons, might be what's behind the Havana effect, have biological effects. Some people are looking at generating forces from here. And then there's the work on to control gravitational coupling. And I just wanted to point out general relativity. It's nonlinear equations. There's 6 equations with 10 unknowns. So there's actually, you set the gauge, 4 gauges in general relativity. Many of those different equations are unexplored and haven't really been fully done, fully analyzed. So that, that can enable propulsion. People are talking about gravitational communication, intersection between magnetic effects and gravity. So those are just some examples of technologies that, are out there, not really proven yet, I would say, but they have the potential to meet what I think is the urgency of the moment and provide an abundant future. Next slide, please. And just I won't talk too much about this, but this is the work I'm doing at the UnLAB fluctuation flow propulsion, where we're directing the flow of these quantum fluctuations in nanostructures to generate propulsion forces. And by engineering an asymmetry through nanostructures and resonant tunneling diodes, we've used standard electromagnetic theory and standard quantum theory to show that a motive force can be generated. So no new physics, nothing like that. But standard analysis shows that a force will be generated, and we're building some structures to validate that force generation. And of course, it enables disruptive performance because there's no propellant, so you can maneuver without regret. And also, since you keep accelerating, you can go to near light speed, only limited by materials. And if you do a rotational device, of course, you can make an electric generator. We are seeking additional investment here to validate and scale the force generation. The first product we see are reaction control thrusters for spacecraft. And just one more quick thing, and on the next slide, this is something my colleague, Dr. Mo Arman, and myself, is really Mo's idea, but I helped him with that. This is a way of generating matter wave beams. So rather than a laser beam, it's a matter beam with fermions. And we're using our Aharonov-Bohm effect to put fermions in coherence, which sounds like, wow, that doesn't sound like that would work. Because you can modify the fermions with no energy exchange. And so we predict that we'll be able to put those in coherent and generate a beam. And people have done those with Bose-Einstein condensates, at very low temperature. But using one of those constraints, Lorentz invariance, well, that fermion condensate is a beam in a different reference frame. So in my mind, that shows you can build a beam out of fermions, a million times more powerful than a laser, plus atomic scale manufacturing and maybe transport of matter over a distance. So So I hope I've been able to convey that we should all have an open mind and that there's huge potentials in the future, and that's what we need to work on and encourage and sponsor the people that are willing to explore these unknown areas.